Okay, this next example, it may look complicated as I'll get out, but it's really not bad. You may want to hold on to your seat a little bit because you need to keep good bookkeeping and you need to apply different or a combination of different techniques on this. But it really shouldn't scare you because this is simply g of x. So in general, if I think of this as g of x, the derivative of k prime of x, is going to equal 3 times g of x squared times g prime of x. That's just the chain rule, all right, using the general power rule and the chain rule. So the question is, what's g prime of x? Well, I need the derivative of the inside, which will require a quotient rule. So it may look big and complicated, but if I haven't ever told you before, the biggest, most complicated, ugliest looking problems you can think of are really nothing more than a bunch of cute little problems put together. So your mission is find the cute little problems and deal with them one by one. Next thing you know, you're done. Piece of cake. So let's walk through this thing. K prime of x is equal to 3 times x squared plus 3x plus 2 over x squared plus 4 squared. See, that's exactly what I have here. Here's my g of x. It's the exact same thing. Times x squared plus 3x plus 2 over x squared plus 4 prime. I need the derivative of this. So let's go ahead and do it. This equals 3 times x squared plus 3x plus 2 over x squared plus 4 squared. I just copied this down again. Now I'm going to start my derivative of that last piece. I think I want a square bracket in there. I don't know why I just did. Okay, so here we go. I need the derivative of the first, which is 2x plus 3 times the bottom, the denominator, as x squared plus 4, minus the numerator, x squared plus 3x plus 2, times the derivative of the denominator, which is 2x, all of this over x squared plus 4 squared. Now, if I were to have given you this problem separately and said find that derivative, you would have thought, oh, piece of cake, because this is a quotient rule with a couple of polynomials, no big deal. You'd have flown right through it. But very commonly, when it's one step along the way of a bigger problem, sometimes we tend to choke and kind of forget that it's just a quotient rule. It's no big deal. So this is just a multiple step problem is all. So from here, I don't know if you want to mess around with this and expand it, try to simplify it or not. I would probably just leave it as it sits. Okay, here's another example. 2 times cosine of 5x squared, quantity squared. All right, it's cosine squared of 5x squared. Now the first thing I'm going to do is I'm going to rewrite this simply. Whoops, I'm going to change colors of my pen. Simply so that we can get a better visual of what's going on. This is 2 times cosine of 5x squared. And just so there's no confusion, this is what's squared. This is my cosine squared. So g prime of x will equal 2 times 2, this is my first 2, my second 2, times cosine of 5x squared, 2 minus 1, so I just have the first power there, times cosine of 5x squared prime. Now when I take the derivative of this is another application of the chain rule. I just applied the chain rule once to get here. I need to apply the chain rule again inside here. So this is going to be 4 times cosine of 5x squared, that's this first piece, times the derivative of this. Well, the derivative of cosine is negative sine, so this is negative sine of 5x squared times the derivative of the inside. See, here's my chain rule again. So I need 5x squared prime. So if I start putting this together, I'm going to pull my negative out. So it's been negative 4 cosine of 5x squared times sine of 5x squared times the derivative of 5x, which is, 5x squared, which is 10x. So now if I put this all together, I'm going to have a negative 40x cosine of 5x squared times sine of 5x squared. There you go.